Here's the review for the next unit. I'm going to explain 1 and 3. 1 is a little problem about the lattice points in the coordinates plane, right? We want to show people is after you plot these lattice points to show these triangles are what? Congruent. But we have very limited resource. This is for young kids to play with numbers. We do not have trigonometry. We do not have similarity. Okay, so we only use the very basic one, distance formula and the congruence to show they are the same angle. And that's the interesting part. Okay. Number 3 is a problem I wrote for AB 10 years ago. I like this problem because very few problems for contest, for lower level contest, have very, very interesting math background. And this, I can say, this problem has a little bit background on that. Because in topology, there is a big theorem. I would not say big theorem. There is some theorem. It's about so-called two homotopy. So basically, it's if you have a region with some good nice conditions, and then you have another region have some other nice properties. What happens is you can cut each of them into 2 sets. Doesn't necessarily have to be connected. Okay, and these 2 sets have the so-called two homotopy property. Set 1, if region 1 is completed, cut into set 1 and set 2, and region 2 is in T1 and T2, you can make S1 homothetic to T1 and S2 homothetic to T2. So you can make completely different regions as long as you can allow yourself to cut them into 2 parts. They can be similar.
Hypothetic means similar in
Yes,
our case.
right? So this is an example. You have a square and a triangle. They are clearly not similar. But I can cut them into 2 parts. For example, one is a square, one is a triangle, one is a trapezoid. Like here, one is a triangle and one is trapezoid. Well, I can make this trapezoid similar to this one, and this triangle similar to this triangle. So that reflects that little theorem, right? Okay. You want to go over number 2?
Yeah, so in number 2, we have a basketball player named Shanil O'Keel, and she makes a number of attempts at free throws throughout the season, and the function S of n is basically going to tell you the number of free throws that she makes in the first n shots of the season. And so the question is, if there are 2 points at one time S of n0 is less than 80% of n0. So at one point in time, her shot
cannot make 80%.
less than 80%. And then in the future, at some other time after n1 shots, it was more than 80%. The question is, yes, she did improve. And the question is it possible to find, or does it necessarily exist some point in between where the number of free throws that she had made was exactly 80%?
So sometime in the season she has less than 80%, and some later part she is more than 80%. We want to know if it's necessarily true. There is a moment she has to be exactly 80%, right? It's possible, for example, if I started with 50%, I have what? 1 out of 2, and then I make another one. I immediately jump to what? 2 over 3, which is 66 blah blah %. So I basically never have to pass what? 60%. Right? So that's still true for 80%. So this is a wonderful problem up here in Podman exam. Mathematicians are basketball fans, right? Hack the Shaq. Shaq cannot make free throws, so Shanil can, right?
Shaquille cannot.
Shaquille cannot, but Shanil can, right? It's a nice, funny story.
Okay, so I'll explain number 4. So in number 4 we have a triangular grid that actually goes to infinity. But anyway, we have an ant that starts at some point, and he goes along the lines, and we are common ways are that for him to go 5 steps and go back to the origin point. So for example, it can be going a triangle and go to it back.
the story about this problem is that a student and a teacher were competing who can solve this problem in their head while having a dinner. That's why we have it here. Number 5 will be the same problem we discussed last time, which you can see in the previous episode. So we'll continue talking about it, about how to divide the rectangle into 2 similar but not congruent polygons.
Right. This time we give a little bit of hint.
Yeah.
In the last unit, we give a hint about solve it partially. Right. This time we have to solve it